The title is Zizifus moritiana extract mediated green and rapid synthesis of gold nanoparticles and its antibacterial activity. This is actually associated with my research work. That's why I have selected this particular paper. This is the screenshot of paper. You can see the same thing, that the journal name is at the upper end with the year of publication, then the volume and the page number is mentioned here. DOI number is there. It received at 7 January 2015, accepted by journal on 18th March 2015, and published online on 9th April 2015. The keywords for this paper is gold nanoparticles, green chemistry, scanning electron microscopy, and Zizifus moritiana, that is ZM, and antibacterial activity. So you can see it highlights all the keywords which are there in the title. Now, what are the contents of this presentation? If we just go through the high impact factor journals, that time this is the required thing, that is graphical abstract. It is required to present your work at a one stage. So that graphical abstract I have mentioned here, the first one. The second one is abstract, introduction, material methods, result and discussion, conclusion and references. This work is actually a blend of chemistry, SUTEX, and microbiology. So actually and ultimately we will going to produce a quality product, so it will link to the quality assurance. Okay. So now what is graphical abstract and what it indicates? Now my first question is, or yes, I must have to be in a student or presenter format. So what is Zizifus moritiana? So Zizifus moritiana is a Indian juju, that is bear. Boar म्हणतो आपण मराठीत त्याला. So that bear, it is, this particular one is from the Iran. So they have taken this species from Iran, that is Zizifus moritiana. In India, the species is slightly different, but they have taken the leaves of this Zizifus moritiana and they have prepared the plant extract by using the particular extract, methanol, hydroalcoholic extract they have prepared, and further they have added it into the chlorouric acid and then studied or characterized for their SEM analysis. This the first picture is showing the SEM image. The second one is the XRD and the third one is EDX. So this, the one single presentation can gives us an idea that this plant leaves we have taken, we have extracted the things and then further we treated it with the chlorouric acid and then characterize it for the nanoparticles or that particular nature of nanoparticle. So this is the graphical abstract given by journal or given in a paper. Being at host and Madhura ma'am, can you allow enable the waiting room? So because I can see the notifications here, so it's not possible for me to see the slide also.
What am I supposed to do? Enable waiting room?
Yeah, just enable the waiting room. And if
it was enabled, now I have disabled it. Okay, what do I do?
Disable it. Just click on
disable it.
Yeah, it is enabled right now because I can see the notifications of waiting room. Yeah, it's done now. Okay. So the abstract is here. Yeah, the abstract given here, the first in this study, the Zizifus moritiana extract is added to the chlorouric acid and it gives The gold nanoparticle, as gold is indicated by AU, so it is gold nanoparticle in the range of 20 to 40 nanometer. This Ziziphus moritiana extract is very good reducing and stabilizing agent. As we are looking for a green synthesis, so it is very important to know the nature of this extract. So most of the phytoconstituents have reducing and stabilizing capability. This reaction stopped within 25 minutes. So the reaction time for this synthesis is 25 minutes. So the formation of gold nanoparticle occurs within 25 minutes. Further, this gold nanoparticle characterized by UV visible spectrophotometry, XRD, FTIR, TEM, that is transmission electron microscopy, SEM, that is scanning electron microscopy. So during characterization, they observed peak at 535 nanometer. It resembles to the gold and it compared with the references also. So it indicates the formation of this gold nanoparticle. XRD results gives us an idea regarding the nature of nanoparticle, that is crystalline nature of nanoparticles of 27 nanometer size. So even we can calculate the size by using XRD. We can measure, the first thing is to determine the nature of that particular gold nanoparticle, is it crystalline or amorphous. FTIR, it played a major role, like the extract OH group, that is a functional group, act in a capping of nanoparticle synthesis. Now being a nanoparticle, most of the time it is unstable. So we need to cap it. So this OH group present in the extract acts in the capping of nanoparticle. TEM is again the one which gives us an confirmation regarding the size of nanoparticle. And the next is the SEM. Now here you can see, which is very different, we will discuss in the result and discussion. The antibacterial activities were tested against the growth of gram-positive bacteria, that is S. aureus, and they confirmed it with the help of SEM. So up till now we are aware with the antibacterial activity or studies by using the zone of inhibition, by determining the zone of inhibition, right? But we can get better results with the SEM analysis. So therefore, the green synthesis of gold nanoparticles with this Ziziphus moritiana extract is beneficial from its biological and medical applications. So this is the abstract of paper which gives us an idea regarding the preparation of nanoparticles, its characterization and its application. Now, the introduction part, what this biosynthesis of gold nanoparticles involves, why we are focusing on nanoparticles. So it is of small size and a biostability one. It is the one which is a smaller one as well as stable one, because if we move towards the smaller size, it leads to the instability. But this biosynthesis may produce the stable nanoparticles, which have applications in biomedicals, and that's why these are important also. Then metallic nanoparticles of specific sizes and morphologies, like if I said the nanostructures that nanodendrimers are there, nanorods are there. So there are different morphologies of nanoparticles are available. Spherical are there. So they are produced by chemical and physical methods. So this chemical and physical methods again enlisted in different way. But this chemical methods have most of the time the more toxic products also in your final formulation or in your final nanoparticle. So in the physical methods, that green methods or green synthesis methods are more preferential. So in this, nanoparticles with a small particle size and a high surface to volume ratio exhibit a new and unique properties in comparison with the bulk material. We all are aware with the nanoparticles. We all are aware with the advantages of nanotechnology and nanoparticles. In recent years, a great deal of efforts has been expended for the natural materials, because natural materials we're using from a long time, but still they are having the applications. They have not developed any type of resistance. They still shows the similar type of antibacterial activities. That's why we have taken here Ziziphus moridiana extract. Among green synthesis methods, the use of plants for nanoparticle synthesis could be advantageous over the environmentally benign approaches like microorganism based method. So there are so many methods for preparation of nanoparticles. So one of them is the using plant extract. Now the use of plant extract, fungi, algae, proteins, enzymes as a reductant for carrying out the synthesis of nanoparticles with a variety of shapes, morphologies in a high yield, including multi-branch advantages, gold or silver nanoparticles. You can see here the reference style is different. Yesterday, the press paper was having Harvard type this referencing pattern. This is Wanker type where we can mention the number. So this is the different type of referencing. So this indicates the references. So it gives us an idea that the paper or the literature available on the plant extract, the use of plant extract and all. Now the next is bioreduction is the one of the fundamental process in this biomimetic synthesis. Now what is the biomimetic synthesis? Where biological material is involved in the synthesis procedure. Why I mentioned the biomimetic synthesis? Here we are taking Ziziphus moritiana. This is the plant extract. It is this origin is the biological origin, and we are treating it with the or we are using for reducing the metal ions. So you will get better understanding with this diagram. So this ME represents metal ions. When we treat this metal ions with the plant reducing agents, that are phytoconstituents, which are with the OH moiety most of the time. So it reduces this metal ions to this smaller molecules. So these are also called as biomolecules. Further, this biomolecules get aggregated, that nucleation occurs, and it used to form the metal nanoparticle. And this metal nanoparticle is having a coat of this OH. Okay, so as I discussed in the abstract part, this OH is acting a capping of this metal ion. So this organic coat stabilizes the particle. So this is the general bioreduction process occurs when we treat phytoconstituents with the metal ions. Now, the stability, shape, size, and morphologies of nanoparticles. We are talking about the generalized nanoparticles. Depends on this particular process, this particular parameters. The method of preparation of nanoparticle, chemical or physical, the type of nanoparticle, like the metal ion nanoparticle, or the sources are different, might be the nature of reductant, which type of reduction is occurring in the process, concentration of stabilizers. Now, why stabilizers are required? Stabilizers are those which carry out the role of capping and stabilizes this nanoparticle. So that concentration of stabilizers include polymers, ligand, solid matrix, and surfactants. So even in case of gold nanoparticle, earlier they have added surfactant. But again, this is the question: if we are adding surfactant, so again we are adding a chemical. So how to resist at the point of toxicity? The next is gold nanoparticles. Now, why the present author selected this gold nanoparticle? It is the one, the surface plasmon resonance and the large effective scattering cross section. This is the one which make it enable or ideal candidate for molecular leveling. Yes, these terms are more physical aspects like surface plasmon resonance. So this is again how the light oscillates from the particular gold particle, or the effective scattering cross section of that gold nanoparticle. This is the area associated with the structure or nature of gold nanoparticle, and which make it ideal candidate for molecular labeling. So we can label that biological molecule with this gold nanoparticle. The size, shape, the antibacterial activity of gold nanoparticles. So by reduction of this Au3 plus ions with bioreductant Ziziphus moritiana, it depends on nature of reducing agent, concentration and time of mixing. As in abstract, we have seen this reaction is occurring in 25 minutes. So the time of mixing is again important one. Concentration, the 1 millimolar of that chlorouric acid is required, and the nature of reducing agent. Now, why this one? Because chemical methods are toxic one, the toxic chemicals as reducing it, preferably use the toxic chemicals as reducing agents or non-biodegradable stabilizing agents, and again potentially dangerous to the environment and biological system. Therefore, the present paper is designed for a green synthesis of gold nanoparticles with Ziziphus moritiana extract. This is an alternative to chemical synthesis. It's beneficial from its biological and medical applications, have a high antibacterial efficacy if we compare it with the plain extract, and a great potential in the preparation of drugs used against the bacterial diseases and physiological stability. So in present paper, the material and method used, the chlorouric acid, it's from Sigma. All other reagents infused in the extract, they all are of analytical grade. The Ziziphus moritiana leaves collected from Demavand of Iran. This is the particular area of Iran. Cleaned with distilled water, then again shade dried for a week at room temperature, ground to the powder and stored. And further, this powder is used for our study or analysis part. Nanoparticles concentration, that the nanoparticles concentration is 0.0976 to 100 microgram per ml. So generally this nanoparticles prepared in the liquid form initially, so it is in the concentration of 0.0976 to 100 microgram per ml. And the antibacterial study is carried out on S. aureus, that is Staphylococcus aureus. This is gram-positive bacterium with 80 cc strain 51153. This 80 cc stand for American type culture collection. So there are two types of culture collection, MTCC and 80 cc. Now, what is the method for synthesis and characterization of gold nanoparticles? So in this process, first we have to take the extract of Ziziphus moritiana. So initially the 2 gram of dry leaf powder taken into the 25 ml of distilled water in a conical flask, and in this solution 2 ml of methanol is added. And this ZF leaf extract further kept in an orbital shaker for 1 hour. And the next step is filtration. So after filtering the same, the solution, that extract, we can use for the synthesis of gold nanoparticles. So that the 1 ml of this Ziziphus moritiana extract added to the 10 ml of 1 millimolar chlorouric acid in an orbital shaker. At a room temperature, it is around 30 degrees Celsius. When we kept it at room temperature in an orbital shaker, this extract consisting of OH group and amide groups also, that reduces the metal ion, and this reduction of this metal ion, that is gold, occurs from this Au3 plus to Au0. And during this transformation, it used to show change in a color. So initially this acid is colorless one, and after 10 minutes it is turning to purple to ruby red. So this is the first indication of formation of gold nanoparticle. So it indicates there is a formation of gold nanoparticle, that the change in the color. Further, the solution centrifuged at 15,000 rpm for 20 minutes, and this pellet is redispersed in the sterile distilled water, and at the end the purified pellet is formed. Now after scrapping this pellet, dried at 60 degrees Celsius for 24 hours. So this is the procedure for synthesis of gold nanoparticle. Now the next is antimicrobial activity studies of synthesized gold nanoparticles. I have taken all the headings as such from the paper. In this antimicrobial study, the same points are mentioned here, the S. aureus with the 80cc strain. Now, what the treatment we are doing with bacterial culture. So this bacteria culture were incubated at 38 degrees Celsius in urea medium. So this media is different and the composition of this media is given here: tryptone, yeast extract, sodium chloride, agar and diphyco. So these are the constituents of this broth. Further, the in vitro antibacterial activities of gold nanoparticles were examined according to the given references. The next is zeta potential determination, that is zeta potentiometer of synthesized gold nanoparticle, where you can determine the stability of gold nanoparticle. So the stability developed by this gold nanoparticle at different pH was analyzed using Malvern zeta sizer, and the pH is in the range of 6 to 12, and the pH is adjusted with 0.2 normal HCl and 0.2 normal NaOH. For characterization, this 4 to 5 methods are there. The one is UV visible spectrophotometry. The details of the spectrophotometers are given here. The analysis is carried out from 300 nanometer to 800 nanometer, because the gold is showing its lambda max in a visible range. That's why we have taken the range 300 to 800 nanometer at a resolution of 1 nanometer for 1:4 diluted of the reaction mixture, and the blank is distilled water here. Next, SEM is carried out and it is equipped with the X-ray energy dispersive spectrometer, that is EDAX, which generally gives us an idea regarding the particular carbon, nitrogen and gold present there. In this case, the 8% leaf extract and 8 millimolar of chloruric acid or solution is used. TEM, that is transmission electron microscopy, is used to confirm the image, that is selected area electron diffraction image. These are the specifications for TEM. Then XRD for studying the diffraction pattern, for studying the nature of the nanoparticle, and the observed reflection planes corresponds to FCC, that is face centered cube. That FCC stands for face centered cube of gold nanoparticle. It is around 27 nanometer. FTIR is there to confirm the changes in the FTIR spectra or the functional groups. So how the OH of COH group get changed or have shown the changes in the peak and all. And in this case, they have taken the powder of Ziziphus moritiana and the powder of pellet of nanoparticle. In this, a drop of 8% leaf extract was mixed with KBr powder and pelletized after drying properly. So 8% of leaf extract can be mixed with the KBr powder. So these are all the methods. The one is the physical observation, that before UV, as I said, the change in the color in the reaction mixture is the one identification mark for formation of gold nanoparticle. So in case of result and discussion, this is the UV visible spectral studies of synthesized gold nanoparticle, which is carried out at 30 degrees Celsius. So in this case, the change in a color from colorless to red color indicates, this is the first indication of formation of gold nanoparticle. The second, that brown color was due to the excitation of the surface plasmon resonance, because of the oscillation in the gold nanoparticle. and typical, it is, this SPR is typical to gold nanoparticle. It is having a lambda max 535 around, so it is in the range of 530 to 550 nanometer, get confirmed with the reference also. So it is confirmed with the reference available. So it indicates there is a formation of gold nanoparticle. This is the first indication. The next one is FTIR studies. In case of this FTIR studies, the first FTIR spectra is associated with the Ziziphus moridiana extract, the raw material, and the second one is for Ziziphus moridiana extract gold nanoparticle. So in the first one, or this particular spectra, the second spectra is showing all the intense peak of 2935, 1629, 1515, 1384, 1156, 1076, 1307, and strong bands at 1702, 1622, 1446. These all intense peak are associated with the functional group or groups available in the Ziziphus moridiana gold nanoparticle. So it indicates it retains all the functional groups. So it will give the same activity as of or might be the additional one as of the raw material and the gold nanoparticle. In this case, if we highlight on few, that is COH group for OH. So you can see in a raw material, this OH group is at 3421, which is shifted to 3391 in the nanoparticle. And again, if you compare the broadness of this peak, it is narrow in case of Ziziphus moridiana, which is quite broadened in case of nanoparticle. So it indicates this OH involves in the encapsulation of this nanoparticle. Further, the C of COH, that is C of carboxylic acid group, that the peak intensity is reduced. The peak intensity is reduced. This is because of the encapsulation of nanoparticle. The next is CN stretching of amine group, that is 1384. In a raw material, this peak is broadened one. In case of nanoparticle, it is narrow and sharper, that is at 1384. It indicates the CN stretching, and it actually gives us an idea that the biomolecules get combined with the gold nanoparticle. So it is actually the amide group is involved in the formation of nanoparticle. OH is playing a role of capping. And again, the C bond stretching at 1702 is less, or we can say very less here, which confirms the formation of this gold nanoparticle. This is all about the predictions from FTIR. The next is transmission electron microscopy. Here the selected area electron diffraction image. So you can see image A and image B is there. These are the TEM images indicating the presence of spherical gold nanoparticle recorded at various magnification. So the two are at different magnification. Okay. So in this too, you can see that 57 nanometer is here, spherical shape nanoparticles are here. Some are 27 nanometer, some are of 5 nanometer. So the shape is spherical. This TEM gives us an idea regarding the shape of nanoparticle. The size is in the range of 20 to 40 nanometer. So the average size is 32. Monodispersed, so there are around similar types of nanoparticles are here. So there are no different other shapes are there. This nanospherical are having the high surface area and the observed reflection plane corresponding to FCC, that is face centered cube gold nanoparticle, around 27 nanometer in XRD diffraction pattern. So it is resembling to the XRD results also. So it gives us an confirmation regarding the shape, that is spherical, size 20 to 40 nanometer. The next one is SEM, that is scanning electron microscopy, where we can determine the surface of nanometer as well as size of nanoparticle. So here the gold aggregate of gold nanoparticles are there, which is in the range of 15 to 35 nanometer. This is the one 16.4. This one is of 39.7. This is 30.9 nanometer. So not in direct contact within the aggregates, but they are indicating the stabilization of nanoparticles by capping agent. As if capping will not be there, there will be aggregation of nanoparticles. So in this case, we can study the stabilization, or we can confirm the stabilization of nanoparticles by capping agent. The next is EDAS. So you can see in case of EDAS, the strong signals are of gold atoms in the nanoparticles and weaker signals for carbon, oxygen, potassium and chloride, were provenient from the biomolecules of Ziziphus moritiana. So it gives us a confirmation for the presence of or the high strong signals of gold nanoparticles, or the presence of gold with bioorganic components of Ziziphus moritiana. XRD. So this is the graph of XRD or XRD pattern of gold nanoparticles obtained using Ziziphus moritiana. We can study the crystalline nature of this. These peaks are sharper one, which indicates the crystalline nature of particular nanoparticle. If it is amorphous in nature, then it should be broader one. So the sharp peaks indicates the crystalline nature of nanoparticle. Then the three diffraction peaks. So on a x-axis, you can see 2 theta. This is the angle. So this three diffraction peaks is in the range of 30° to 80°. In this case, we used to check the diffracted rays. So generally these diffracted rays have a particular angle, which can be indexed as 111, 200, 220, 311. These are the reflection.
Seems there is a network issue. Maybe ma'am will be getting back in a minute.
There are total 8.
Hello, Neha ma'am.
Madhura ma'am,
Yes, we can hear you.
I think I have, yes, I have disconnected for some time. So I'm going through this exercise again. So we can determine the crystalline nature. We can determine the particle size with the help of this Debye-Scherrer equation. And by putting the values of this, we can get the around the size of this nanometer, that is 27 nanometer. and it is in good agreement with the TM results. So ultimately, we can claim we have synthesized gold nanoparticles which are a pure crystalline gold. Now, how to get confirmation for stability of synthesized gold nanoparticle? You can see zeta potentiometer. That zeta potentiometer is used to check the stability. So that zeta potential is plotted on a y-axis, and the pH is on x-axis. So as increase in a pH, there is an increase in the zeta potential. It is from minus 22.3 to minus 65.0 millivolt. So it indicates more stability towards increase in a pH, as it has shown better stability in the range of 6 to 12, and highest or more stable is at 12. This leaves extract mediated synthesized nanoparticles have high negative zeta potential value, and thus they are stable under wide pH range. More negative zeta potential, more will be the stability. And in this case, at 12, the more zeta potential we can see. So the more zeta potential in a negative, high negative zeta potential value indicates more stability. How to get confirmation, or how to get the plus of this nanoparticles, like antimicrobial activity of gold nanoparticles? So in this case, up till now, you are aware with the zone of inhibition studies, where we have the agar diffusion studies. But in this paper, I have seen a different aspect, which is more, or which we can say better one. Initially, they have carried out that zone of inhibition, and for confirmation, what they did, they have just added this S. aureus, that bacterial culture, to the urea medium, and in the same one they have added the extract. The first image represents the addition of extract, and this black arrow represents the colonization of S. aureus. In first image, you can see more colonization is there even after addition of extract. And in case of second image, the colonization is decreases. This scale is of 10 micrometer, and it is seen under SEM. So it indicates that the nanoparticle is having better efficiency and better antibacterial activity in comparison with the plain extract. So the same indicated that the most strains of S. aureus were damaged and extensively disappeared by addition of gold nanoparticle. So it indicates this gold nanoparticle is having better antibacterial activity. So these are all the results and discussion. So what we have concluded from this paper, that gold nanoparticles were produced by the use of this extract Ziziphus moritiana as a reducing and capping agent. The reaction is rapid and is completed within 25 minutes at room temperature. So it is environment friendly also, as well as it is taking very less time. It is an eco-friendly rapid green synthesis chemistry approach for synthesis of gold nanoparticle using Ziziphus moritiana, which provides a simple, cost-effective and efficient way for synthesis of gold nanoparticle. The average crystal size calculated from this shaded equation is found 27 nanometer for gold nanoparticles by using XRD. The spectrophotometric characterization of UV visible, FTIR, TEM and zeta potential support the formation and stability of biosynthesized gold nanoparticle. This simple, efficient and rapid green synthesis of gold nanoparticle can be used in various biomedical and biotechnological applications. So even we can work it further on antibiotic resistant species. So in present paper, he has tested it on a normal strain. Therefore, this reaction pathway satisfies all the conditions of 100% green chemical process. The same indicated that the most strands of SORES were damaged and extensively disappeared by addition of gold nanoparticle. Thus, the synthesized gold nanoparticle could have a high potential for use in biological applications. So we can use it in the human applications also. So this is all the conclusion of the present paper. These are the, I have quoted some references here just to show you the type of referencing. It get differed with the journal as well as paper. Thank you so much.